All right, in this video we're going to explore the implications of the fundamental theorem of algebra in one direction. I'll do a different video to explore it in the other direction, I'll let you read most of this that's on here for yourself. You're able to do that. But the basic idea here is that if we have a polynomial, as in our example here, of degree 4, then that means there should be 4 answers, and those answers might include some multiplicity of one root occurring over and over, or some of those roots could also be imaginary or complex. So we are going to try to find all 4 of the answers here, whatever they may be. Following my own tips that I've included on here, we've generated a graph of the polynomial portion of this, and we can see by combining with the rational root theorem, which would tell us that we have numerators of possibly the factors of negative 14, so plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. My denominators are all plus or minus 1s in this example. I should probably complicate that in a future video somewhere, but not today. And I can see from my graph that the negative 2 appears to be a root and the positive 1 appears to be a root. So I'm going to use my area models to get those out of there. If x plus 1 is a root, or if positive 1 is a root, then that means x minus 1 should come out of this thing. And so we will build this. The x to the 4th goes in there. That means this is an x cubed, and that's a minus x cubed. And I'm supposed to end up with negative 3 x cubes. So that means I need another negative 2 x cubes here, which would mean this has to be a negative 2x squared, and that would make this a positive 2x squared. And the x squareds, I'm supposed to end up with exactly 1 x squared. So that must mean I have a negative 1x squared here. And if that's a negative 1x squared, then this must be a minus 1x, which makes this a positive 1x. My x's, I'm supposed to end up with 15 x's, so that must be 14 of those x's right there, which means that this would have to be a plus 14. That makes this a minus 14. These were supposed to add up to a negative 14. That leaves me the remainder of 0, so it came out cleanly. And so far, I have x minus 1 times x cubed minus 2x squared minus x plus 14. Now, if I had started with the x plus 2 over here, I would have gotten a different looking situation here, but it still would have gotten me moving in the right direction. Now, following my second piece of advice here, once I've pulled this x minus 1 out here, I'm going to do the rest of my work on this cubic. Okay? It should still have that x plus 2 as a root, so I'm going to set that up with my next area model. And that's an x cubed. That should be in there, which means this must be an x squared, and that makes that a 2x, and the things on this diagonal, 2x squared, and the things on that diagonal are supposed to add up to negative 2x squared, so I must have a negative 4x squared to make that happen, which makes this a minus 4x and forces this to be a minus 8x, and my linear parts up here were supposed to add up to a negative 1x. So I must have had a negative 7x up here. And of course, if that's going to be a negative 7x, then this must have been a minus 7. which makes this a minus 14, and something, I'm sorry, this was supposed to be a positive 7x, which makes this a positive 7 and a positive 14. And these things were supposed to add up to a positive 14, and they do, and I get my 0 remainder, so that came out cleanly. And so what I have now is the x minus 1 that I took out in the beginning. I just took an x plus 2 out of what was left with that, and I'm left with an x squared minus 4x plus 7. My graph is telling me that the only answers that are possible are -2 and +1, and I've taken both of those out already, so what's left here must not factor, or I would have seen it show up in the graph. So I will verify that by checking the discriminant on just this part, now that I'm down to a quadratic. If I do my b squared, which would be 16, that's my b squared, minus 4 times 7 times 1, and that's a 16 minus 28, which is a -12. So clearly this is not going to factor, and because my discriminant is negative, it means I'm going to have complex roots. So let me go ahead and find those complex roots. They're going to be at x equals the opposite of b, so there's 4, plus or minus the square root of -12, already found the discriminant, divided by 2a, which is 4 plus or minus, that's going to be, what, a 2i root 3, all over 2. Clean that up a little bit more. I'll take a 2 out of the top, so that the 2 divided by 2 becomes a 1, and I'm left with a 2 plus or minus I root 3. Those are two of my answers. They are complex roots there. And so my three answers, or my four answers, sorry, are where x minus 1 is 0, x plus 2 is 0, so that's at x equals 1, at x equals -2, and at x equals 2 plus or minus I root 3. There's the four answers that were promised by the fundamental theorem.